Hi everyone, how are you doing? Okay, so let's get started. Sahil is saying, is probability in CSE engineering mathematics same video as in GATE DA probability? Yes, so this is the start of module 2, which means the module 1 is same as GATE CSE and the module 2 will be different. Okay, so these are the new lectures which will be different than GATE CSE lectures, right? Okay, so this is module 2. Now, let's see that what we have seen regarding the random variable in module 1 itself, right? Okay, so see here that we have seen that what are the type of random variable already, right? So these things we have seen, and then random variables, these things we have seen. Okay. Then we have done few questions. For example, let's suppose this is a question where they are saying that suppose that a coin is tossed twice, right? Let x represent the number of heads that come up. Then write down the PMF of x. So number of heads. So if you're tossing it twice, then it could be zero. I mean the value of x could be zero, or could be one, or could be at most two. Can it be three? Tell me. Can it be three? Obviously no, right? It cannot be three. So if you're tossing it twice, then at most it can be two. So it can be 0, it can be 1, it can be 2, right? Okay. Now, what they're saying next, let's just see that they're saying write down the PMF. PMF means what is the probability that it takes the value, for example, 2. What is the probability that it takes the value, for example, 1, like that, right? So we need to write down all the probabilities. So I think that's easy. What is the probability that it takes the value 1? Or it takes a value 0, which means that there is no head, which means only tail, so it is 1 by 4, right? So that's how we solve this question. Similarly, we saw multiple questions. For example, this is the PMF that is given to us, and now they are saying that this is for this PMF, check is this a valid PMF or not. So for that, what you need to do, you need to sum all the things, and you need to check whether all the probabilities are getting to 1 or not, right? Similarly, let's suppose this is for pair of dice. I think there's a question like that. There are multiple questions, right? For example, I think this is another question. So they're saying find the value of k. So we need to add all the probabilities, and that will be just one, right? So that's how we can find the value of k. Now, in this particular question, this is basically regarding the joint probability distribution, right? Joint mass function, right? So in this particular question, what they are saying that note that one of the table entry is missing. Okay, let's suppose this is missing. Determine the missing entry. So they are saying that they determine this entry. Now, if you have seen this particular lecture, now we have already told that if you want to find out this particular entry, then what you can do? Tell me. You can sum. I mean, what concept we can use? The concept will be the sum of all the entries including this entry will be 1, right? So let's suppose this is x or this is k, then sum of all the entries should be 1. Is this fine to everyone? Sum of all the entries in this particular table. So this was the first one of the first example there. We have used the joint probability distribution, but in the module 2 we will see that this little more. Okay. Okay, so more questions we have seen, right? Okay, Ankita is asking, what are the prerequisites for attending today's class? I will say that the basic of probability mass function is good enough. So if you have seen the probability mass function lecture, which means this particular lecture from the module 1, then it is good. Okay. Okay. So I think a few of the things we did in this particular lecture. Okay. Now let's just see. I mean, let's just again see this joint probability mass function in this video. So we will be approaching this topic directly with the questions, which means the basics you might be knowing. So we will be just directly approaching this topic with the questions. Let's see if we are able to solve it or not. Okay. So suppose this is the very first question that we have. Let me say it is a question number 1. What they are saying, the following is joint probability mass function for the random variables x and y, which means this is the probability. This is the probability that is given to us for x equal to 0. We will say this is a probability for x equal to 0 and y equal to 0. Let me know if that is okay to everyone, right? Okay. So this is the probability which is given for x equal to 0 and y equal to 0. Now, what they're saying, they show that, okay, so show that this ultimately the C is 0. So how we can show? Any idea? What we can do to show that C is finally 0? So basically, we can show that add of if I sum all of these entries, including the C, yes. So including C, which is 0, then it should be 1, right? That's very easy. So you can quickly check if the sum is 1 or not. Okay, so this is 30, this is 30 and 30, 60, 60, 80, 90, 90 plus 15, right? Which is 105. So I think this is sum is 1. Okay, if you don't include the C. So that's why C will be 0, right? So if you sum over all of these entries, then it should be 1. That's how we can show this. Okay. I think this is fairly easy question. So I hope you understood this, right? How to solve this question. So this is just introduction to this joint probability mass function. Let's just see more questions. Okay. Most of the questions will be like that only. So today I don't want to make it very heavy. Like, I mean, it might be ultimately, eventually it might be, but I will try to make it, like lighter, lighter lecture, in the sense that we will not be deeping down into much of the complexity. Okay, we will be just understanding one of the concept, which is joint probability mass function in this particular lecture. So let's just see this second question. The discrete random variables x and y. Okay, so sorry, this is capital X and Y. You can understand like capital X and Y, doesn't matter. Okay, so x and y have a joint probability mass function given like this, right? So what does this notation mean? Can anyone tell me what does this notation mean? It means I think I have used this kind of notation little bit in the module 1 also, right? So what does this mean? It means that I'm talking about x and y. So basically, this is capital X, which is equal to small x, comma capital Y, which is equal to small y. Do you know this notation? How many of you know this notation? That if I'm writing, okay, if I'm writing something like this, so let's suppose if I'm writing something like this, what does this mean? It means I'm saying probability of x equal to small x equal to C, right? So basically, this is a joint probability, right? So now what they're saying, that let x, range of this x, okay, could be 1, 2, 3, and range of the y could be 1, 2, and the function equals 0 otherwise. So basically, this is the only range of x, this is the only range of y. Now what they're saying, determine the constant C. So they're asking you that if x range from 1 to 3 and y range from 1 and 2, okay, then what is the value of C? That's what they're asking. So tell me, if this x that can range from 1 to 3 and y can range from 1 and 2. So what will happen? How many total possible values? 6 possible values, right? So this is, let's suppose x, this is y. Now this is 1, 2, 3, you can say 1, 2, 3. Okay. Now for this one, let me write 1, 1, 1. Okay, this is 2, 2, 2. So these are the possible pairs of x and y. Now, what is the probability of getting 1 and 1? This will be C. What is the probability getting 1 and 2? You can just multiply. This will be 2C. This will be 3C. This will be 2C. This will be 4C. This will be 6C. Now, if you add all of this, it should be how much? It should be 1, right? So that's why, what is the answer here? What is the answer? Okay. So answer is 1 by 18. Okay, 1 by 18. Yeah. So one of the student, Hasti, is saying that 1 by 18 is answer. So which is indeed the answer, right? Why? Because if you add all of this, you will be getting, if you add all of this, you will be getting, it should be actually 1, right? If you add all of this. So it is basically 18C, which is equal to 1. From here, you can say C equal to 1 by 18. Okay. So that's how you can find out the value of C. So let's just see. Yes, C is 1 by 18. Now the question doesn't only ask the value of C. They are saying determine the value of constant C and, okay, and compute the marginal probability functions. So do you know what is a marginal probability function? Do you know about this term? We have talked about this term in the module one, right? Marginal means they are only talking about this x. This is marginal, right? This is called marginal. This is called conditional, right? This is called conditional. And this is called, sorry, this is called joint. And this is called conditional. Conditional distribution, right? And this is called marginal distribution. Understood? Okay. So now what they are saying is that we need to find the marginal distribution also. So as we know that C is coming out to be 1 by 18, right? So marginal distribution means that what is the probability if X is getting 1, what is the probability that X is getting 2, like that, right? Okay. So C is 1 by 18, which means 1 by 18 into XY. So let's just see what is the probability that X is getting 1. How to find out this? This should be, this should be how much? Tell me. Y is ranging from 1 to 2. Okay. X is ranging from, you can say, 1 to 3. This is given in the question. So if you want to find out probability of X equal to 1, then what it will be? It will actually be probability of X equal to 1, and then you can marginalize this. What does this marginalization mean? You can plug in Y equal to K, something like this, right? For all K. How many of you remember this formula? This marginalization? How many of you can relate? Just tell me yes or no. Okay, so Diksha is saying she remember. Okay, anyone else who remember this? See, this is easy. We have already talked about this in the module 1. So what I'm saying here is that if you want to find out the marginalization, right? If you want to find out, let's suppose the probability of X equal to 1, then it is just like the total probability, right? You can just say that, okay, this is with all the values of Y, which means it will be probability of X equal to 1 whenever Y is 1, or plus probability of X equal to 1 whenever Y is 2. So what is this probability when both are 1? This probability is C, right? I mean, I can later on plug in C as 1 by 18, which is fine. But this is actually C, right? And this is 2C. So finally it is 3C. Okay, which means 3 by 18. Okay. Now similarly, you can find out probability of X being 2. So what is the probability of X being 2? So what you can do, you can actually make a joint distribution table itself, which means you can find out all of these values first. So whenever, okay, this length is more, so I can write X here. Is this fine? I can write X here. 3, this is, let's suppose Y equal to 1, Y equal to 2. So that's very easy. What you can do, you can just multiply, right? This is C, this is 2C, this is 3C. This will be just a double of this, which is 2C, 4C, and 6C, right? Now they're asking this will be 3C, right? This will be 6C, this will be 9C, like that, right? So it will be 3C, 6C, 9C. It will be How much is the probability that y is being 1? Tell me fast. What is the probability that y is being 1? Yes. So it will be 6c, right? Similarly, what is the probability that y is being 2? You just need to add all of this. This will be 12c. Okay. So like that, you can find out the marginal probabilities also. Okay. So it is, I think, easy enough. Okay. Now let's just move to the next question. Okay. So what they're saying, toss a pair of fair die, right? Let x be the smaller number tossed and y be the larger number tossed. So you're tossing a pair, right? You're tossing a pair. So let's suppose that whatever is the smaller number, that is x and larger number is y. Then find out the probability mass function, which they are representing with f. So fxy. So basically they are saying you're tossing, right? So in the toss, how many possibilities are there? I think for x, it is, you can say it can range from 1 to, right? Y can also range from 1 to 6. Okay. Now, uh, suppose if 1 1 appear, okay, if 1 1 appear, then in that case, so they are saying x is the smaller number and y is the larger number. If 1 1 appear, then x is 1, y is 1. If 1 2 appear, then x is 1, y is 2. If 1 3 appear, then x is 1, y is 3. If 3 1 appear, then x is how much? Again 1 only, because x is the smaller number, right? And y is 3. Is this okay to everyone? Just quickly tell me. Suppose if 4 and 3 appear, then what is the value of x and what is the value of y? 3 and 4, right? Is this okay to everyone? Because x is the smaller number. For example, if 6 and 6 appear, then x is 6, y is also 6. Okay. So now I hope you got it, that how to write x and y. So now what they are saying, that what is the joint mass function or joint probability mass function for this particular setting. So how to find out joint probability mass function? Let's just see. So there are 16 possibilities, right? Okay. So you want to try it for 1 minute, for 1 or 2 minutes? Just try it. Okay. Just see that if you are able to solve. So basically here, let's suppose if I ask you, okay, let's suppose if I ask you, what is the probability that x being 1 and y being 2? What is the probability that x being 1 and y being 2? It means I'm asking you, another way of asking is that at what kind of combination, okay, what kind of dice combination you will be assigning x as 1 and y as 2? Whenever you get 1 and 2, right? Or you get 2 and 1, then also x is 1 and y is 2, isn't it? So basically, out of 36 combinations, 2 combinations are there where you will say that x will be 1 and y will be 2, right? Isn't it? Similarly, you pick anything. For example, probability of x being, let's suppose, 5, y being 4. Tell me, is this what is the probability here that you assign x as 5 and y as 4? What do you think? What is the probability? Is this even possible to get x as 5 and y as 4? If you get 4 5, you will say x is 4, right? If you get 5, 4, you will say x is 4. X is always a smaller number. So the probability is 0 here, right? The probability is 0. So which means if x is greater, then obviously we are not much interested there. Okay. So if x is greater, then the probability will be 0. if if y is greater, or maybe both can be equal, I will come to that case. But if y is greater, for example, probability of, if I ask you, x is 4 and y is 5, if y is greater, then what is the probability? You will be getting this assignment in two cases. And what are those two cases? Whenever you get 4 5 or 5 4, right? You will be getting the same assignment, which means 2 by 36, right? So now tell me this probability. When you will be assigning these two numbers, at what kind of coin, or what kind of dice combinations? Whenever both are getting 3 and 3. So what is the probability here? 1 upon 36, isn't it? Okay. So you can say, if you want to write PMF, then you can say that probability of x equal to, let's suppose, I, comma, y equal to j, right? It will be, let's suppose these are the three cases. Okay. Suppose I is greater than j, I less than j, I equal j. Can you tell me what are the answers here? If I is greater than j, then what is the probability? What do you think? The probability will be 0, right? As I just told you. Because if x is 5 and y is 4, it is not even possible, right? Y is 4. Because I will assign x always a smaller number. So that's why this probability is 0. If y is greater, then yes, then it is good. In that case, it will be how much? Yes, 2 by 36. In this case, it will be 1 by 36, right? Oh. Now, just for the sake of, extra practice, if I just ask you that, how many such cases are there where this I and j both are equal? 6 cases, I think, right? 6 cases. 6 cases are there where I and j both are equal. So remaining are how much? 30 cases, right? So among those 30 cases, this must be equally distributed. So I think these are 15 cases. These are also 15 cases, right? Now you do one thing. You do just, add all of these probabilities. So it will be 2 upon 36. How many times? 15 times, right? So I can just multiply by 15. I mean, there are 15 such probabilities, and these are the 6 such probabilities. So basically it is 30 plus 6 upon 36. It should be 1. Okay. It is just a quick check. Okay. So one of the student is saying that, can you show the question again? Okay. So yeah, this is the question. Now I hope you understood, right? Cool. So this was just a quick check whether our calculations are correct or not. Now let's just see what is the probability that by being 2x. Okay. So what is the probability that by being double of the x? It lies under which case? I think it lies under this case. So what is the probability? I mean, it will be kind of 2 by 36, but how many 2 by 36 will be there? That's why it is interesting, right? So basically you can say it will be, I mean, for one of the case, it will be 2 by 36, right? But is this just 2 by 36? Tell me, can I say it is 2 by 36? No, right? So it is falling under this case, but how many times by will be, double of x? So x can take the values 1, 2, 3, 4, 5, 6. So if it is double, then y must be, okay, for this is 2, for this is 4, for this is uh, 6, right? So I think for only these three cases, okay, 1, 3, 1, 2, 3. Then if x is 1, 2, 3, then y will be 2, 4, 6. Okay. So you can say, okay, just to write it more clearly, you can say it is nothing but probability of x being 1, y being 2, plus probability of x being 2, y being 4, plus the probability of x being 3, y being 6, right? Now tell me what is this probability? Now you tell me what is this probability. Once you have the concrete numbers, what is this probability? Yes, this individual probability is 2 by 36, right? So this probability is 2 by 36 plus 2 by 36 plus 2 by 36, which is 6 by 36, right? Which is 1 upon 6. Okay. So yeah, so this is the answer. Okay. These all are 0. Oh, so on the diagonal, they are getting 1 upon 36 if both are equal. Above the diagonal, they are getting 2 by 36. Below the diagonal, this will be just 0. Okay. Have you understood this question? Let me know. Can we take equal case in question if given in question it is given x greater? I didn't get it. So what you are saying? X is a smaller number, right? In the question. Okay. Yes, they are saying it is always a smaller number, right? Okay, no, if you are getting one and one, if you are getting one and one, then what is the value of x and what is the value of y? If your toss outcome, if your experiment outcome is one and one, then what is the value of x and what is the value of y? So here, in those cases, x and y both will be equal. Okay. If your outcome is equal, then in that case, the x and y both will be equal. Okay. Now let's solve this. Suppose that x and y have discrete joint distribution. Okay. Which is PMF is given, joint PMF is given like this. X can range from -1, 0, and 1, and similarly y. Now they're saying what is the value of this constant c. Okay. So basically it is defined like this: c into x plus y. Okay. Or 0 otherwise. So if the value of x is -1, 1, and 0, similarly, if the value of y is -1, 1, and 0, then it is like this. Otherwise, it is 0. Okay. Now, what is the value of c? So basically, there are 3 into 3, 9 combinations. So how to find out the value of c? So what you can do, you can write this. Maybe you can make a table quickly. -1, 1, and 0. -1, 1. Okay. -1, let me write 0 and 1. Okay. So how to do this? You will be just adding it is x plus y, right? Yeah, this is x plus y. So here it is -2, which means 2c, right? Here it is, I think 1, which means just c. Here it will be 0. Here it is again 0 minus 1. So I think it is 1c. It is 0. It is 0 and 1, which is 1c. So again, this is 0. This is 1c. This is 2c, right? Okay. Now what you need to do? You need to add all of this. So how much is it is? 3c, 4, 5, 6, 7, 8, right? So what is the value of c? So if you add all of this, then what is the value of c you will be getting? 1 by 8, right? So this is 8c is 1. So from here, c is 1 by 8. Okay. So this is the answer. C is 1 by 8. Now they have asked, I think, something else also. So what they're saying, can you find out these probabilities also? Apart from the C, can you find out these probabilities also? Let's just check. Okay. So given this, can you find out these probabilities? So what is the probability that x being 0 and y being 1? I think this is the probability, right? X being 0 and y being 1, right? So this is the probability, which is C. So this is just C, which is 1 by 8. What is the probability that x being 1, which means you need to add all of this? This is 3c, right? This is 3c, which is 3 by 8. What is the probability? This is, I think, little interesting. What is the probability that x minus y mod is less than 1? Okay. Tell me, in which cases x minus y mod less than 1? If you subtract this, then it is 0. 0 is less than 1, right? Because both are equal. So if you subtract, 0 is less than 1. So it is satisfying the condition. What else? Is this satisfying? -1. Let's suppose this is x. Okay. And this is y. Okay. This row is y. -1, uh, -0. This is just 1. 1 is less than 1, right? 1 is not less than 1. So it will not satisfy. See, whenever x and y, yeah, whenever x and y are equal, this will satisfy. Whenever x and y are equal, this will satisfy. Apart from that, apart from that, I don't think anything else will satisfy, right? Because less than 1 means since this value, since it is positive, then it can be either 0, can be 1, can be 2. Less than 1 means only 0, right? Only 0. Since it is positive, so it could be 0, 1, 2. Okay. I mean, given that values of x are ranging in this range, right? So I think only 0 will satisfy, right? Okay. So this diagonal. So how much it is? I think it is 5c, which is 5 by 8. So 1 by 8, 3 by 8, and 5 by 8, right? 1 by 8, 3 by 8, and 5 by 8. Oh, sorry, this is 4 by 8. Just a second. Yeah, sorry, this is 4 by 8. This is 4c, which is 4 by 8, right? So that's how you can solve this question. This is also, like, I can say it is easy one, right? Okay. Now, let's just see this question. So let's see how to solve this question. So what they're saying, the joint probability mass function of x and y is given like this. Compute the conditional mass function. So in this case, they're asking you to find out the conditional mass function, in the sense that you need to find out probability of x equal to 1. Okay, I mean equal to anything, basically 1, 2, or whatever, right? So let me just tell you the notations. See, this is the notation for the joint distribution. Is this okay to everyone? Joint probability. Okay. This is the notation that we use for marginal. This is the notation. Just see here. This is the notation given by. Now, since y is given, then typically we write the value also. Okay. See, the difference is that that in the x I'm not writing the value. Okay, which means I'm not saying x equal to k. Okay, I mean this I can say it's not an issue. What I mean to say, I can say x equal to, let's suppose, k1, given that y equal to k2. Tell me, will it be just a complete distribution by itself, or it will be just one number? Tell me, this will be just one number, or it will be a complete distribution by itself? If I denote like this, what do you think? What do you think? I'm saying y equal to k2. Given that y equal to k2, what is the value? What is the probability that x is k1? So I think it will be just a number, right? Just a single probability. Is this okay to everyone? It is just a single probability. But instead of writing like this, if I write like this, where I keep the possibilities of x open. Here I'm keeping x open, here I'm keeping both, right? Open. So these are the distributions. So this is what we call conditional distribution. For example, for example, let's suppose I say probability of x being 1. Will it be a single number or a complete distribution by itself? It will be just a single number, right? Do you agree with this? Now, instead of this, let's suppose I say probability of x. I don't assign any value. It means I'm saying I'm talking about the PMF. This is the PMF notation, right? Which means here I want to say, tell me what is the value of x being 1, what is the value of x being 2, what is the value of x being 3, and so on, right? Understood? So this is the PMF notation, probability mass function notation. Similarly, here, tell me, if I just ask you, okay, if I just ask you that this thing and this thing, if I just give you two options, okay, suppose this and this, which is PMF, one or second? What do you think? Which is the conditional PMF, conditional probability mass function? So this is, again, this is a single number only, right? Single number. Because I'm talking specifically, but this is the conditional mass function. Is this understood to everyone? Let me just know. Okay. Now what they are saying is that compute the conditional mass function of x, which means for given that, okay, so they're actually asking for y equal to 1 also, y equal to 2 also. So let's just find out the conditional mass function for given y equal to 1, okay, and then we can find out for y equal to 2 also. So they have given you the joint distribution. Now we need to find out the conditional distribution, which means let's just first find out probability of x being y equal to 1. Is this a conditional distribution? Yes, right? So which means they're saying x is actually ranging from 1 and 2, right? Okay, y is also ranging from 1 and 2. So what is the probability that x being 1, given that y being 1? Similarly, what is the probability that x being 2, given that y being 1? And then I will also find out the other conditional, which is this one, right? So which means they are saying what is the probability? So just find out these four probabilities. Okay. So let's just find out these four probabilities. Do you want to try it? Let me know. Okay. So how you can approach? Just think about it. So this will be how much? The probability of x being 1, comma y being 1 divided by probability of y being 1. So what is the probability of y being 1? If y is 1, you can just, add both of this. This is 2 by 8. So basically x and 1, so it is 1 by 8 upon 2 by 8. So which means this is 1 by 2, right? Is this okay to everyone? How we did it? See, this is the formula that you might be already knowing, right? Right? So we have already seen this formula. How many of you are familiar about this formula? Okay. So I think most of you are familiar, right? Now, what is this probability? This is already given to us, right? Which is 1 by 8. So the first probability is already given to us, which is basically 1 by 8. The second one is probability by being 1. This will basically be, I can get it using the marginalization, which means y is 1 and you change the values of x. So it will be 2 by 8. Okay, you sum it will be 2 by 8. So which means some quantity divided by double of this quantity. So it will be 1 by 2. Similarly, let's just find out this. So probability of by is 1 and x is 2 comma 1. So it is 1 by 8 divided by probability of by being 1, which is again 2 by 8. So it is again 1 by 2. So probability of x is 1 and y is 2. X is 1 and y is 2, which is 1 by 4 divided by probability of y is 2. Y is 2 means you add both of this. So how much it will be? It will be 3 by 4, right? 3 by 4, which means 1 by 3. Now last one, this is 1 by 2 divided by 3 by 4. It is 4 by 6, right? Which is 2 by 3. Okay. Tell me, is this fine to everyone? Now, interestingly, if there are just two probabilities, then if you just find one of them, can you not find another one? Yes, right? Do you remember the tree diagram? See, using the tree, you can visualize this. That if you're conditioning, if you're saying, okay, y equal to 1, right? So you can say that y could be 1 or it could be 2. Given that y is 1, what is the probability that x is, so here x could be 1, x could be 2, like this, right? X could be 1, x could be 2. So basically for both of these branches, the probability summation should be 1, which means given that, yeah. So if I'm writing 1 by 2 here, then automatically 1 by 2 here. If I'm writing 1 by 3 here, then automatically 2 by 3 here, right? So this probability is actually given that y is already 1. What is the probability that x is 1, right? Okay. So like this also you can understand this, right? If you know one of the probability, then in the conditional, I mean in the reduced sample space, you can find out another probability by just subtracting from 1. Okay. So I think that's all they're asking, right? Okay. There are more questions. For example, they're saying, are x and y independent? So how to check if x and y are independent? Anyone? So what we can do to check that x and y are independent? Yes. So what we will be doing? Let me just tell you. See here. We need to check for every value. Okay. For every value, we need to check that we need to check for every pair. This should hold. What is that? X equal to some value, y equal to some value, equal to probability of x equal to that value, probability of y equal to that value. For every pair it should hold. Okay, for independence. Yes. So which means what is the, by the way, what is the probability of x being 1? You can sum over by's. So it will be 1 by 8 plus 1 by 4, which is 3 by 8. What is the probability that y being 1? Y being 1 means you need to add these, right? This is 2 by 8. The other probabilities we already know, which means x being 2 means it is, you can subtract, which is 5 by 8. And similarly, by being 2 means 6 by 8. Okay. So you need to check for every. So let's just check for 1, 1. So if you check for 1, 1, it will be 1 by 8 on the left hand side. And then it will be 3 by 8 into, 2 by 8. Is this satisfying? No, right? Or yes, let me check. This is 4. Okay, I think it is not satisfying, right? So which means for 1, 1, it fails. So it is not independent. Okay. So no, because for 1, 1 itself, it is failing, right? For 1, 1 itself, it is failing. Okay. So x equal to 1, y equal to 1. It is basically 1 by 8. And this is 3 by 8 and 3 by 8. So it fails. It fails for 1, 1. So it is not independent. It should be satisfied for all the pairs, as you already know, right? So that's why it is not independent. So, you can say, are x and y independent? Then answer is no. Compute this. Okay. So which means they are saying that what is the probability that xy multiplication of xy is less than 3. So how to compute this? So let's just go to the next page. How to compute these terms? What do you think? We need to compute these terms. So when will be xy product xy less than 3? So less than 3 means they are saying either it could be 1 or it could be 2, because given the values, it cannot be anything else, right? So when it could be, when is the possibility that probability of xy less than 3 means we are saying probability of xy equal to 1, or probability of xy equal to 2. So so when is the possibility that that product is 1? Then both are 1, right? Whenever both are 1, x equal to 1 and probability of y equal to 1. Plus, what is the probability that the product is 2? X is 1 and, sorry, they are not independent. Sorry about it. So I need to write with the comma. X is 1 and y is 1. Okay. What is the probability that they are 2? Whenever x is 1, y is 2, or x is 2 and y is 1. So you need to add these three probabilities. Okay. Apart from 2, 2, you need to add all of this probability. So it will be 2 by 8, which is again 1 by 4 plus 1 by 4. It is actually 1 by 2. So ultimately it will be 1 by 2, right? Let's just check this. Okay. Let's just see the next question. Probability of x plus y greater than 2. So when it could be greater than 2? Greater than 2, is this even possible? Yeah. I think with these values, it will be directly 4, right? So when it could be 4, x plus y 4, only at this, right? Sorry, it could be 3 or 4. It could be 3 or 4. Okay. X plus y greater than 2 means it could be either 3 or 4. So when can x plus y be 3? Whenever either x is 1 or 2, 2, 1, 1, 2, 2, 1, this thing, and 2, 2, right? These three you need to add. So which means you are leaving out this, which means this is how much? If you're leaving out 1 by 8, then it is 7 by 8, right? Okay. So 7 by 8 should be the answer for the next one. 7 by 8, right? Okay. So now let's just check the last one. Probability of x given that y is greater than 1. Which means given that y is 2. So which basically they are saying, right? I think we have already calculated this. Probability of, no, this is not given. I'm sorry about it. I think this, they're not asking for like this. This is, I think, division, right? So I think this is division. So division is greater than 1. When can division be greater than 1? Uh, Greater than 1 means I think this could be only 2, right? Okay. Division cannot be more than 2. So when it will be 2, whenever x is 2 and y is 1. So it is 1 by 8. Okay. Whenever x is 2 and y is 1. Is this okay to everyone? This whole question, how we are calculating these values? Let me know. Okay. Okay. See, x plus y greater than 2. Is this understood? It means that greater than 2. When can addition be greater than 2? It could be either 3 or 4, right? Here they are saying this is division, by the way. Here they are saying x must be 2 and y must be 1. Then only division will be 2. Okay. You just need to figure out that on which values these conditions are being satisfied, and you just need to add all of this. Okay. If already joint distribution is given, then that is very straightforward. You just need to add the numbers because the joint distribution is already given to you. Right? Okay. Now, now let's just see the next question. So what they're saying that consider, right? Consider the following PMF, probability mass function, which is given to us. Now, something like this, right? Determine the following. Show that probability of x comma y is valid probability mass function. How we can show it? You just need to add all of this. Yes, just need to add all of this, and it is 1. So let's just find out this probability that x is less than 2.5 and y is less than 3. So when can this be satisfied? What is the value possible to, what is the possible values of x? Less than 2.5, which means it is either 1 or you can say uh, either 1 or 1.5, right? Either 1 or 1.5. And what about y? Y is less than 3. So it should be either 1 or 2. So which means when can this condition be satisfied? Whenever whenever x is 1 and y can take the value 1, right? So you can say x and y. The table will be like this: 1 and 1. With this one, it can take 2. With this 1.5, it can take 1. And again, with this 1.5, it can take 2. So these are the 4 possible combinations upon which, right, either x and y take this value, then also these both conditions are satisfied, or x and y take this values, then also this conditions are satisfied, or x and y take these values, then also this condition is satisfied, or x and y take these values, then also this condition is satisfied. So basically, there are 4 cases under which this condition is satisfied, right? So this is 1 1. You need to add 1 1, 1 2. Okay, there is no 1 2. Okay, which means that probability of 1 and 2 is 0. Okay, that's okay. 1.5 and 1. Is there is any 1.5 and 1? Okay, there is no 1.5 and 1. There is 1.5 and 2. Yes. So you just need to add all of both of this, right? Is this fine to everyone? How to do this? Okay. So this B is just adding both of this. So if you add it, which means it will be uh 2 by 8 plus 1 by 8, which is 3 by 8, right? So for part B, it should be 3 by 8. Is this okay to everyone? You just need to add these two. Okay. So remaining is actually 0. Okay. Do you want to try these questions as an homework? I have the solutions in the slide itself. Okay. So you can try, right? These are the easy questions only. So just try this as an homework. See here, you just need to list out all the pairs, okay, all the pairs for which this condition is satisfied. You just need to list out all the pairs. So basically here, you don't have pairs, so you can marginalize, which means x is less than 2.5, which means x is 1. You need to add x being 1 and 1.5. So for 1, what is the probability that x being 1? Can anyone tell me? For this, with this 1, you need to marginalize this, right? Probability of x being 1 and then y being 1, y being 2, like this. But there is only non-zero is only by being 1. So it is just 1 by 8. Okay. Probability of x being 1 is actually same as probability of x being 1, comma y being 1. Is this okay to everyone? Why probability of x being 1 is same as x being 1 and y being 1? Why I'm not adding anything? Generally we add, right? But why I'm not adding? Because if you add anything, any other thing, then it is anyway 0, right? Y equal to x being 1 and y equal to 2. There is no combination 1 and 2, which means it is 0. Okay. So that is why I'm just saying like this, right? Okay. Anyway, so you can do all of this question. These are easy questions only. Try this, okay, as an homework. Definitely try. Don't escape. Okay. Don't escape. Because these are the little things. Once you understand them, then only you will be able to solve the complex questions. And even like these kind of questions have been asked in not last year gate da, but I think these kind of questions have been asked in gate CSE. Okay, at least in gate CSE they have asked these kind of questions. But I'm sure in gate D also, it is very much possible that they can ask this question, one part of this question as 1 mark. Okay, it is a potential gate question. Okay, it's not like that they will ask any only tough questions or something like this. It is definitely a potential gate question. Okay, so answers are on the next pages, right? Okay, now let's just solve this question. What they're saying: a wheel of fortune has numbers 1 to 3 on it. So it means like either if you spin it, you will be getting either 1 or 2 or 3. Assume that each spin of the wheel, the probability that outcome is 1 by 2. Probability of outcome is 1 is 1 by 2. Probability of outcome is 2 is 1 by 3. And then probability of outcome is 3. What is the remaining probability? Can anyone tell me? This is 3 by 6. This is 2 by 6. I think 1 by 6, right? 1 by 6 is the remaining probability. Okay, this is written. Okay, I thought it is not written. Suppose we spin the wheel twice and let x be the minimum of two numbers obtained and y be the maximum. Okay, so x is some other random variable. So let's not write x here. Okay, so if you're spinning it twice, let's suppose this is some other. If you're spinning it twice, then they are saying x is the minimum of 2 and y is the maximum of 2. So out of 1 to 3. Okay, so you will be getting, I think this is little similar to what we have already done, but let's just do it again. You will be getting either 1, 2 or 3, right? Okay, so what is the probability that x being 1 and y being 2? X is the minimum, right? Okay, so when can you get 1 and 2? Whenever either you get 1 2 or 2 1, isn't it? Right? Either you get 1 2 and 2 1, which means see, when can you get x as 1 and y as 2? Whenever on the wheel spin. Okay, either if in the first you get 1 and then 2, or you get 2 and 1, right? What is the probability that you get 1 and 2? First you get 1. What is the probability? 1 by 2. Into what is the probability that then you get 2? The probability is given as 1 by 3 plus the probability is here 1 by 3 into 1 by 2, right? Okay, so for this is the probability. Now, can you find out all the possible pairs? So let's just do this. 1 2 3, right? Let's suppose these are the values of x, these are the values of y. Okay, you want to write the values of x on the horizontal or on the vertical? We can do any ways. So maybe x on the horizontal. Is this fine? These are the values of x, these are the values of y, let's suppose. Okay, cool. Now let's just see that what are the probabilities. These are the probabilities for the wheel. Either you get 1 or you get 2 or you get 3, right? And these are the probabilities for the same. Okay, now you tell me, is this possible? X is actually the smaller number, right? X is the smaller number. So is this possible to get x as 2 and y is 1? No, right? This is 0. X cannot be greater, I think, right? So I think these numbers Yeah, these three numbers will be 0. Okay, what is the probability that x and y both are 1? You are, sorry, you are doing what? You are spinning it twice, right? Okay, I think this calculation is wrong. Sorry about it. You are, this is not a pair or something, so I made it pair. You are spinning it twice. So what is the probability that you get, 1 comma 1, x as 1 and y as 1? What should be the, the outcome of the experiment in the first trial, in the second trial, what should be such that your x and y is basically 1 and 1. This should be 1 and 1, right? Okay, which means 1 by 2 into 1 by 2. What is the probability that x being 1 and y is 2? So you're tossing it, or you are spinning it twice. So what is the probability that x being 1 and y is 2? Either you get this. Okay, sorry. The earlier thing was correct only. 1, 2 and 2, 1, right? So it is 1 by 6 into 2. So which is 2 by 6. Like that, you need to fill this table, right? 1 by 4, 2 by 6, like this. So it is 1 by 4 and then 2 by 6 or 1 by 3. Both are the same thing. Like that, you need to fill this whole table. Okay. Okay. Can you do this now? Can you try doing this as an homework? It is also easy, right? Okay. So I have done it partially. You can just try to do it, okay, fully. Because solution is there. So that's why I'm just expecting that you can do it. Let me know if that is okay. Okay. So I think this is fine. Now let's just move to the next question. Okay, here we have many things they have asked. So they're saying the joint probability distribution of two-dimensional discrete random variable x, y represented in the following table. Okay, this is y. This is given as y. This is given as x, right? Now, can you calculate the probability that x is less than or equal to 2? Which means x is either 0 or 1 or 2. So you need to add all of these probabilities, right? All of these probability, if you add, then you will be getting, see, the probability of x being 0 is this, probability of x, sorry, yeah, x is this, okay. So probability of x being 0 is this, x being 1 is this, x being 2 is this. So if you want to get x is less than or equal to 2, you need to add all of these probabilities, right? So let's just see the answer. X equal to 0, x equal to 1, x equal to 2. You need to add all of this. They've already calculated, I think, marginal probability for x and y. If you add, this is 0.27, okay? You can do this. If you add all of this, it will be 0.27. Y greater than 1. Y greater than 1 means it could be either 2 or 3. So can you tell me which row or which columns? Just tell me the row number or column number which we need to add to calculate this probability. Y is greater than 1, right? So 2 and 3. So you need to add both of this. Yes. So last two rows, right? Last two rows. Now, x is less than or equal to 1 and y is less than or equal to 1. So it means, what are the possible values of x which will be satisfying? I think x could be 0, could be 1. Y could be 0, could be 1. So 0 and 1, right? Less than or equal to 1. I think these all four values, right? These are four values if you add, because only 0, 0, 0, 1, yeah, 1, 0, 1, 1. This will only satisfy, right? These all four values you need to add. So how much it is, by the way? This is 0.2 and 0.2, 0.04, right? So the C should be, so let me just quickly verify. The answer of C should be 0.04. So 0.04 is the answer of C. Okay. Now let's just try this. X greater than 3 and y equal to 2. By the way, do you want me to solve these questions in the next class if there is any doubt? because I want you to practice. I want you to, focus that, okay, how to solve. And then finally just take some time. Maybe if this question is, let's suppose, taking half an hour, then also it is okay. Okay. Because until and unless you spend some time, then you will not be getting it. So it is just a calculation, just a, mental practice that you need to do. So what you do, like, you can just spend half an hour just for this question. Okay, try as much as possible. Answer is there on the next page. Try all of these questions. Okay, these are approachable. It's not like that these are not approachable. Okay, and then the solution is there. You can verify with the solution. Okay, this is D, this is D, this is E, this is F, this is G, this is H. Okay, so these are H parts. C, B, A. Okay. Sorry, these are the I. So I think I will be on the next page. Okay. So just try out. Okay. Just try out these parts. Is this fine to everyone? Okay. Okay. So I hope you are getting this joint distribution. Do you think this is tough? Is this seeming to be tough as of now? Okay. So I think this is approachable. Okay. With the little bit of more practice, you will be able to, solve these kind of questions. Not a very tough question, I can say. Okay. Now let's just see this. Yeah, so Diksha is saying it looks easy, but mistake occur. Yeah, it is just because we are studying it very first time, but after some practice, you will get more confidence that, okay, how to solve these questions. So basically, whenever they are, asking for some condition, just see that what are the possible values of possible pairs of x and y which are satisfying this, right? For example, this. What are the possible pairs of x and y which are satisfying this? Okay. Now they are saying, given that y equal to 2, okay, x is greater than 3. So, which means greater than 3, which means they're saying 4 and 5. So, x equal to 4 and x equal to 5. Given that y is 2. So, how to solve this? Okay. Just think about it. That how to solve this. So, see here, x will be 4 and 5. Greater than 3 means this is greater. Okay. Greater than 3 means either 4 or 5. Right. Okay. Now let's solve this question. What they're saying, x and by the integer value is random variable. Joint probability distribution is defined like this. Are x and y independent? What do you think? How to solve this? We need to check. So here P and Q are some numbers which summation of them is coming out to be 1. Okay. We need to check for every possible value of x and every possible value of y such that this should hold, right? Which means the probability of x equal to m into probability of y equal to n should be equal to probability of x equal to m, comma, probability of y equal to n. Now here you need to find out the probability of x equal to m first. Okay. Let's suppose these are the infinite. Okay. N could range to infinite. So how to find out this probability? Probability of x equal to m. So basically, see here, these numbers are basically less than 1. Okay. It's not like that if this is infinite, then it will, blast or something. It will diverge. Okay. These numbers are actually less than 1. P plus Q, P and Q both are actually less than 1. Okay. So do you want to try this question? Let me just tell you what you can do. See, here we want to check whether this holds or not, right? To check the independence, we want to check whether this hold or not. Then we need to first calculate what is the probability of x being m. Then how to calculate it? You will be basically doing summation over all the possible values of y, right? Probability of x being m, comma y. Okay, is this fine to everyone? So which means, if you want, I can write it n here, which is all the possible values of n, right? All the possible values of n. So n is basically can go from, I think, from 0 or 1. Okay, from 1 to any value, which means n is from 1 to infinity, and this is n, all the possible values of n. Which means you need to actually sum this. So I think q square p power m minus 2 into p power n. Can I write like this? Okay. So q square into p power this m minus 2 is actually independent of n. So you can take it outside of the summation. Okay. Which is now p power n. Now this is a GP. Okay. This is clearly a GP. So which is p plus p square plus p cube. Do you know the infinity sum? A upon 1 minus r, right? P upon 1 minus b. Do you remember this? The summation of infinite GP, A upon 1 minus r. So it will be q square into p power m minus 2 A upon 1 minus p, right? Like this. So we will be getting some little complicated like this. Okay. Similarly, you find out y equal to n, the probability of y being n. How to find out it? In the similar way. Okay. So should I do this or you want to try? Let me just show you directly. Okay, they have directly got this. By the way, for x equal to n, they have got this formula q into p power n minus 1. So are we simplifying in some way? If 1 minus p is actually q, right? 1 minus p is q. So it is q and q, they are cancelling out. So it is q into p power m minus 1, right? So this is actually q and this q and q will get cancelled out. So it is q into p power m minus 1. Understood? Similarly, you find out probability of y being n. Just give it a try. Just see if you are able to do it. So how we will be doing it? Let's suppose I want to find out probability of y being n, which means I will range over all the m, right? Okay. So I will range over all the m, and this is fine. This is, I think, fine. I will range over all the m. Now you can take whatever is, not dependent on m, you can take it outside. It is q square p power n into p power minus 2. Okay? You can take it outside. So it is 1 plus p square plus like this, right? Sorry, p plus p square plus like this. So what you can say about this? This is p upon 1 minus p, right? So what is the final answer? This and this will get cancelled out again. Okay. So you can say this is getting cancelled out with this. This is q into p power minus 1 and n minus 1. P power n minus 1, right? Earlier what we got? Q into p power m minus 1. Here it is n minus 1. Let's just verify it. Yeah, n minus 1 and this is m minus 1. Yes. So basically we have got probability of x being m as q into p power m minus 1. Probability of y being n as q into p power n minus 1. And what is the joint probability that is given to us? This is given to us as q square m plus n minus 2. Q square p power m plus n minus 2. Okay. Now tell me, is this hard to verify whether both are independent or not? No, right? So you can do this easily. So from this, you can say both are actually independent, right? Because multiplication of these two is actually this, right? So you can say x and y are independent. Okay. So this was very good question. I think you understood this, right? Hopefully you understood this. So how to solve this question? You just need to find out the individual probabilities. Okay, cool. Was there any other part? No, this is the only thing they're asking. Okay. Now like that, actually there are little more questions. I think there are few more questions. So do you want to try these questions as an homework? The solutions are there. Okay. So you can just try all of these questions as an homework. Right? I mean, these are just a repetitive kind of question. So we can solve, if there's any good question, we can solve it tomorrow in the class. It's not an issue. But before tomorrow, you just try out. Okay. Just try out. Actually, there are some good questions also. For example, this question. Here we have defined the new random variable. Okay. And then they're asking few things. So I think this question is good. So just try out all of these questions for your own, goodness. So you can consider all of these questions as an homework, and we can have one more session to solve the homework only. Okay, but first try these questions so that you will get the confidence, right? Whenever you get more practice, you automatically get the confidence. Okay, so we will be having one more session just to solve this homework, but I want you to try all of these questions, because then only you will be getting more, I can say, confidence. Okay, so this is a good question, right? I think this kind of question we have solved, right? Minimum, maximum, these kind of questions we have solved. So this is a good question. Similarly, yeah. So this is also good question. What they are saying, that PMF of XY is given to you. So joint PMF of XY is given to you like this as a table. Okay. Now they are saying, what is the joint PMF of X square and Y square? This is interesting. So just try all of this. Okay. Just try out these questions. Answer is on the next page, but you try out. Okay. Before seeing the answer, you just try out all of this. So I think you will be able to do few of them. Okay. If not all of them, then few of them you will be able to do. Right. Okay. Okay. So we will meet in the next class. Okay. Thank you. Thank you so much. If there is any doubt, you can just let me know. Okay. Great. Thank you. Take care. Bye.